Well, I'm going to show you a couple cursors that we can use, Pete, with the matrix heat map display. Maybe a lot of people don't know a lot about this particular display and the cursors we can use. So let's grab some data first. So the great thing, as you know, Pete, about these matrix heat map displays is like if you have a bunch of data and you want to look for trends easily and quickly, it allows you to do that visually. So and it works with a lot of different types of data. For example, we have some order data from some TPA different paths. Why don't we select all of this data? And I'm just going to drop it into the middle here. And what you need to do is set up the heat map matrix heat map, I should say rather, so that it makes sense for the data that you've dropped in. So why don't we go with section value? Right now we have lots of data and third order, second order, sixth, etc. But it could be frequency sections or whatever the case may be. So it makes sense for us to set this y-axis here to section value, and we will set the attribute we're going to look at on the x-axis here to TPA path, right? So immediately, Pete, when you look at this, I can say right off the bat, looking across this whole RPM range, 1,000 to like 4,500, this second order at body point Y has the highest amplitude, highest sound pressure. Now, if I tried to do
Yeah,
this for
that's that's very fast, but oh, and it's not as obvious when you look at it in a 2D display. But Charles, aren't we supposed to be doing stuff with cursors? I think I'm
I'm
going to
going
win on a technicality.
no. I just wanted to highlight the value. We're gonna get to a cursor here in a second. Um, let's maybe go to DB. So this is what I'm saying,
Oh,
Pete. So if you had to like look through all of that and tell me what's
which
the
one's the
important
highest?
path, yeah,
Yeah,
you would
that'd be
you
kind of hard.
that'd be hard, right?
Yeah, the heat map shows it a lot better, but it has nothing to
Exactly.
do with cursors.
No. Well, I'm gonna put a cursor on here, right? So
Oh,
if I add a range cursor, which we don't use maybe very often, right? And let's say I just want to zero in on this peak,
oh, it's a different
right?
one at that
Right.
peak, huh?
But yeah, between 1600 and 2000 RPM, now I see this body point path 5 is the most important. And I was like, oh, it looks kind of interesting down here as well. Um, or this peak, you can still see it's
All right.
still body point 1. So very useful. Now, like I said, it works with a lot of different data types as well, Pete. So let me show you another cursor that we can use with this matrix heat map. So I'm going to remove all these curves and just grab some FRFs. And let me just hold shift, select them all, drop it over here. Now, once again, we need to set up our matrix so it makes sense. So we're going to here go maybe degrees of freedom, right? And on the x-axis, we will go reference, right?
All right.
Now, one thing I didn't show you yet was that we can look at the data with several different metrics. The last time we were looking at those order cuts, we were looking at the linear complex average. You can do amplitude average, RMS, and then you have some more related to like cross powers, FRS, or things with phase. We have FRAC, frequency assurance criteria, phase assurance criteria. Let's just go with FRAC for now, right? And in fact, I will remove this just for the second. So we're looking across the entire frequency range here. And what the FRAC is telling us is how similar our FRS are. For example, if it's
In shape, not
in
in
shape.
phase though. That's what
Right.
the pack does.
You're right on the money. So to give you an example, let's do another detached display. And I'm going to use my cursor, Pete, now, my cross cursor, since you're being a stickler about that. I'll add a cross cursor. And let's choose maybe this particular point. And if I go to processing, clicking on it, you'll see I'll have the block and its reciprocal is automatically selected for me as well. I can drag that in and Maybe you'll just do dB so it's a little easier to see. And we can see that, yeah, you see that value is close to 1. Those FRFs similar in shape. But if I were to go here, we can see that not so much across certain parts of this frequency range. And you can also still, Pete, go up here. And if we're holding down the control, add a cursor, I can add a range and say, I'm just interested in this frequency range, right? Where it's
Hmm.
probably more interesting.
Yeah, a lot
You
of
can,
people are like, it's hard to bring up their driving points and stuff. This just brings them up automatically, huh? The
yeah,
reciprocal FRF. Damn,
exactly. Just searches through your
darn you,
data.
Charles.